6.2, day 2. Now we're going to talk about infinitely many and no solution situations, and then real life word problems. All right, so if I'm looking to solve a system of equations using substitution, just like yesterday, I want to look to see if I have a variable by itself already, otherwise I need to get one there. This time I have an x by itself, so wherever I see an x, I'm going to plug in this instead. So when I rewrite this, I will have 3.5 times negative 2y plus 4, still plus 7y, all equals 14. Then I'm going to distribute. I'll have negative 7y plus 14 plus 7y equals 14. Okay, then I'm going to try to combine like terms. Negative 7y plus positive 7y actually cancels out. That gives me 0 y's, so I'm left with 14 equals 14. Okay, there's nothing that I can do here. That means, and 14 does equal 14. So if you get it down to something like this, where you can't do anything else and it is a true statement, this becomes an infinitely many solutions situation. Okay, letter B. Over here, I have both of these have a variable by itself. I'm just going to take, oh, no, they don't. Just the first one. Sorry, the first one does. So I'm going to take this and plug it in right here. So I will have 3x minus 11 minus 3x equals negative 13. I'm going to combine these like terms, but 3x plus a negative 3x actually cancels out, and I'm left with negative 11 is equal to negative 13, which is not true. So if I'm down to a not true situation, that is what a no solution looks like. All right. How many solutions does this one have? This would be a great place for you to pause it. Get one of those variables by itself. Ooh, this one maybe you want to do with me first, at least at the beginning, and then pause and see if you can finish it. Because when I'm looking around, I don't have any variables by itself, and I don't have any variables without a coefficient. But what I'm noticing, they purposely did this just to trick you maybe. They put the x's and y's in different places. But if I put this one in the other order, if I wrote 3y plus 2.5x equals 4, okay, same equation, just moved the x and y's around. Notice that this first one is 2 times the size of the second one. So if I take this whole thing and I multiply by 2, which is an option, I will have 6y plus 5x equals 8. Okay, then if you notice, this equation is exactly the same as this equation. And remember when we talked about graphing, if they were the exact same equation, they would touch at every single point. So this one is also an infinitely many situation. All right, real world. A snack bar sells 2 sizes of snack packs. A large snack pack is $5, and a small snack pack is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs did the snack bar sell? All right, so we have 2 situations. One of them talks all about money. Okay, we have to decide what our variables are going to be and then define them. So I'm going to say that x is my large snack packs and y is my small snack packs. Okay, then if we're talking about money, we know that there was a total of $220. And that was made up of our large snack packs, which are $5, so 5x, and our small, which are $3, so 3y. That is our first equation for this system. We still have this number right here, the 60 snack packs. So now we know that we also have a situation that's not talking about money. Okay, so this whole first one, we knew those numbers went together because they were all talking about the money. The second one is actually about number of snack packs. Okay, this 60 is a total. And what makes up the 60? It was the large ones plus the small ones. Okay, so there's our two equations that make up our system. Okay, now we have to use that system to figure out how many smalls they sold. So we're looking for just smalls. All right, so we are going to try to get one variable by itself since we don't have that yet. We're trying to figure out how many smalls. So I'm gonna maybe try to get this y by itself, meaning I want to be able to plug something in for x. Okay, so if I take away y, x is going to be equal to 60 minus y. Okay, so up here, wherever I see an x, I'm going to put in 60 minus y. So it'll be 5 times 60 minus y plus 3y equals 220. Okay, when I distribute, 5 times 60 is 300 minus 5y plus 3y equals 220. Okay, combine my like terms and I get 300 minus 2y equals 220. Subtract 300. Negative 2y is equal to negative 80. Divide by negative 2, and I find out that y is 40. That means that I sold 40 small snack packs out of the 60 that were sold total. Okay, this time a school bookstore is selling t-shirts for $8, sweatshirts for $12. Last month, the bookstore sold 37 t-shirts and sweatshirts combined for a total of $376. How many t-shirts were sold? Okay, so again, we're going to define our variables. They're selling t-shirts and sweatshirts, so I'm going to say X is my t-shirts, Y is my sweatshirts, and then we're going to write our equations. The first one can be all about the money. The second one will be about actual product. Okay, so I know that my total is 376. The other things that have to do with money are the $8 per t-shirt plus $12 per sweatshirt. Okay, I know that there was a total of 37 shirts sold, and that was made up of t-shirts and sweatshirts. All right, we are trying to figure out how many t-shirts were sold. So we're going to need to have the X by itself. So I'm going to make sure that I can substitute in for Y. All right, so I'm going to try to get the Y by Y alone so I know what to plug in for Y. Okay, so that means I have to subtract X and find out that Y is equal to 37 minus X. Okay, now wherever I see a Y up here, I'm going to plug in 37 minus X. So 8X plus 12 times 37 minus X equals 376. I'm going to distribute. 12 times 37 is 444, and then 12x. Combine these like terms. That leaves me with 444 minus 4x equals 376. Subtract the 444, and negative 4x equals negative 68. Divide by a negative 4. And I find out that we sold 17 t-shirts out of the total of 37 shirts. All All right, last example for this lesson. A student bought 1 box of crayons and 5 reams of paper for $54. She bought 5 boxes of crayons and 3 reams of paper for $50. What is the cost of each box of crayons and each ream of paper? Okay, so each one of these situations, the first pack of things she bought and the second pack gives you an equation. Okay, this first one is 1 box of crayons and 5 reams of paper for $54. Okay, in this situation, X is crayons, Y is paper. Okay, the second equation was 5 boxes of crayons and 3 reams of paper for $50. Okay, now this time I don't have a variable by itself, so you get to pick whichever one you want. This one actually looks, if you erase the 1, since we don't have to put 1s in the front, we can easily get X by itself by subtracting 5Y. So this one will actually become 1X is equal to 54 minus 5Y. Okay, so we're going to take 54 minus 5Y and plug it in here when I rewrite my equations. Okay, 5 times 54 minus 5Y plus 3Y is equal to 50. When I distribute, 5 times 54 is 270 minus 25Y plus 3Y equals 50. I'm going to combine my like terms. For 270 minus 22Y equals 50. Subtract 270. Okay, 50 minus 270 gives us a negative 220. I'm going to rewrite this over here. This cancels, so I have negative 22Y's is equal to negative 220. Divide by negative 22. And I find out that Y, or the reams of paper, is 10. Okay, 10. Then I have to take what I have, since I need to find both. I need to go and plug that in to find my X. I'm going to plug that right back in here, because X is equal to 54 minus 5 times 10. 54 minus 50 tells me that the crayons were $4 each, while we saw that the reams of paper were $10 each. Okay, that's the end of 6.2, solving system by substitution. You should be able to complete page 371, 11 through 21 odds, 23 through 24, 26 through 30 evens, and the lesson quiz.